My name is Gregory Schmidt. I'm a fifth-year general internal medicine resident at the University of British Columbia in Vancouver, Canada. I have the great fortune to be able to spend my fifth year of training here in Kenya working with AMPATH on their electronic health record system and healthcare system delivery. This is a presentation I did as part of the OpenMRS community on some ideas on how the electronic health record can be redesigned to really optimize the system for tablets, desktops, and phones. I became fascinated in electronic health record interface somewhere around first year in residency. And the idea of trying to create really complicated data displays intrigued me. And I've gone through thousands of different interfaces from different sectors over the years. As part of my interest several years ago, I really got into the works of Edward Tuffy, and he's the godfather of the visual display of quantitative information. He was a professor at Yale, and I bought the autographed books of his series. There's also some other works that he wrote which were published in The Lancet many decades ago, and they still are, I think, some of the best works on the ways which we can better display data, which is such a crucial part of the electronic medical record. And a few years ago, I came to the conclusion that the Bloomberg trading terminal is probably the most unbelievable machine when it comes to the visual display of quantitative information. I am amazed at the data density which we find on this Bloomberg trading terminal here. And as a general internist, I revel at the ability to be able to view such dense patient data on my computer one day too when taking care of patients. And this was really the prototype that I used 3 years ago when I came up with some concept designs for a concept electronic medical record back in second year residency. But at the time, I was imagining a record which was on a huge high-resolution 27-inch monitor. Maybe it was actually on two 27-inch monitors. Well, the situation is a bit different today. I have the great fortune, as I mentioned, to be working here with AMPATH in Eldoret, Kenya. And we have a point-of-care electronic medical record system that runs off tablets. Some users have Chromebooks and a few laptops. The system runs on an Angular front end, and it connects to a Node.js backend, which ultimately stores the data layer using OpenMRS. And the challenge that we are facing is that because the point-of-care electronic medical record is actually so popular right now, more departments are wanting to use it. The system was originally developed for HIV care, and we're finding that we have to scale to now new departments such as hypertension, diabetes, cardiology, oncology, dermatology, acute care. And as the system scales, we're needing to develop most of the functionality which you would require in a full-service EHR. And this is particularly challenging because, as I mentioned, the system runs off of tablets and desktops, with the desire to ultimately also have it available on mobile phone. And we have a very wide selection of users who use the product. There's community health workers who may have never used a computer in their life, and they need a very simple system that they can use to register patients, to input blood pressures, and to do simple questionnaires. The bulk of our middle users, such as nurses, clinical officers, are people who primarily use a tablet, and their work involves a combination of form-led questionnaires, where there's specific questionnaires that they go through to collect information about clinical encounters, but at times they need to multitask and be able to view concurrently a medication or some past notes or some past vital signs as they work in their workflow going through the visit questionnaire. And then we have the power users. Admittedly, as in any organization, there's not that many, but these would be the clinicians or the consultants, and Of course, the GIM physicians who may be posed with more difficult or perplexing patient cases, and you really need to be able to go in and unpack the medical record, to lay out all the information contained within the record, and to see what could be the cause or the underlying diagnosis that you're looking for. Sometimes these clinicians are in a more standardized clinical workflow, but being able to have a ability to display dense data is kind of what they would be looking for. And the big difference between developing medical records here in Kenya versus in North America is in North America, I find our users generally cut the electronic health record a fair bit of slack in its shortcomings. But here in Kenya, all of our users judge the system whether it is as easy and as fast to use as the apps that they have on their mobile phones, which is admittedly quite a high bar to try to meet. And part of the reason we're also trying to think right now about redesigning our front end of the point of care system is because as we look to scale point of care to many users in the coming 12 to 24 months, we ultimately want the training and the onboarding to be as easy as possible. Today, what I would like to do is address three things. First, to derive from first principles a user interface that is optimized for multitasking on mobile, tablet, and desktop. Then move into the second part, which is to identify 5 ways to sort and group medical data and propose a single interface to do this. And then third, look at some early drafts of specific panel designs for the EHR. And the big reason that we're doing this is we're looking for some direction and feedback from OpenMRS community and any other clinicians and users of the system on the general framework. Because if the general framework looks okay, we can then start to build a wireframe prototype in HTML and CSS just to test if the interactions in the interface and screen flow works as we think it does. Admittedly, in anything in interface design or in design, the moment that you finish that work, you're already disappointed with it. This is essentially a cut at October 1st, 2018 of where the drawings are at. As I draw them, essentially there's things I want to change, and some of them, especially near the end, are very rough. So this is by no means what the final product should be considered. It's just a slice in time. Let's move into part 1, a multitasking, multi-screen interface from first principles. Well, the first principle would be if we have a tablet, do you use it in portrait mode or landscape mode? Well, I'm a big fan of portrait mode, and here's why. When reading, vertical height is one of the most important things to look at, and that's because the eye likes to group text, which is a column that is not too wide, and to skim vertically down. This is in part why newspapers are columnated. Columns also make much better use of space, and so increasing the vertical height of the screen I feel is an important design component. You'll note here just the amount of data you can look at between the BBC News in portrait mode versus landscape mode. And the difference becomes even more acute when you look at these screens with a keyboard up. The landscape screen becomes almost unusable when compared to the portrait mode. In fact, the portrait mode contains 1.5 or 1.47 times more space than the landscape mode does in these examples. And you'll also see the space here is much more usable. So it's more space and more usable space. Now, multitasking is an important component of the record. As we said, some users may want to be able to read the patient chart and work on a clinic note all at the same time. So we need to split the screen. There's 2 ways we can do this. We can either split it down the middle or we can split it in half. There's, I guess, theoretically a third way. You could overlay a box which you multitask in, but this is not ideal. It covers up the content underneath. The exact position of this box is variable and therefore is hard to standardize a workflow for. And you also end up with what I would call dead space. So everything between the edge of the box and the screen edge is not really usable space. And so your actual usable space is now twice as less than you would have if you had gone with one of these other models. So let's focus on these two examples. Now, in the top, we have portrait mode. At the bottom, we have landscape mode. And each is split either with a vertical or a horizontal separation. You'll see the worst combination is landscape mode split horizontally. There's practically no usable space here. The second worst, or maybe tied, are these two models here, where the vertical height is roughly similar between both devices. And I think the best one, because of the fact that it really optimizes the vertical height, is the portrait mode split vertically down the middle. You'll see, though, there's a few other reasons why this is a really good and preferential interface design. Let's imagine this on a desktop. If we split the desktop horizontally, well, this won't work because we are again limiting the vertical height. Also, when was the last time you used a website which had two separate panels split across the middle of your screen like this? It's not common. Now we look splitting the site vertically. We're able to have two very usable workspaces side by side. And that content could, in responsive mode, easily adapt between these two different shapes. They're close enough. The other advantage using the vertical split is that we can tile and have three separate workspaces, or actually you could create four separate workspaces, or each workspace, the width of that workspace is sufficient to contain all the different components designed for the interface, and you're able to tile multiple spaces together to be able to actually have four different spaces of concurrent multitasking. Or it leaves the option to have space 1 be an index, which controls space 2. And this is a really great reason to like this design here. The third question is, how do these work on mobile? Well, if you take a small mobile phone and you split the screen in half, you'll have almost no usable space in either panel. So this will not work. Therefore, really the only option we have is to split the screen in half. And there's a nice way to do this. You can take the panel we have here. We can imagine this is the clinical notes, the records, the medications, the labs, the tests, and we can transpose it full screen onto the mobile phone. Then we can take the panel here, which could be your action panel, the clinic note as you write it, or the order sets, and we can superimpose this panel over top of the underlying clinic note. And the user can go, when they need to write their note, pull up the panel from below, view the medications or labs, write their notes or write orders, and if they need more space, operate this overlying panel in full screen mode. When you don't need it, it can be recessed. And you'll see that the general shape of the mobile phone, of the tablet, and of the desktop follows roughly the same ratio of proportion, which means that the components we design for one device will be able to easily tile across all three. Now, is this crazy? No, everyone's doing it now. It's called a bottom navigation drawer. Well, not a navigation drawer, it's more just a bottom drawer, but it works really well. We have both Apple and Google Maps both using it in their applications, and it's a great way to multitask. To summarize, we have split our screen vertically down the middle. Now, in order to control the two sides, sometimes people may be inclined to put a left arrow here and a right arrow here, or multiple arrows to pull these panels left or right, or you may want to put an expand icon on one side to expand the panel and then a contract icon to contract it. I think a more simple solution is to place one single button at the bottom of the screen, which the user can use to pull to the left to expand the action panel, or pull to the right to expand the clinical note. And of course, you can always reset it to the middle to view both at the same time. Now, we talked about the importance of standardized panels. Here we have the split screen design, and we have a standardized panel shape, which we know is going to work on mobile phones and is also going to work if this panel is on desktop. And if the user scrolls to the left and makes the clinic note full screen, we have the option of, rather than splitting this column into two separate columns, so we can see more information at once rather than having to scroll down to get it. Or we have the option to take the panels and make them go widescreen. For instance, you could imagine that this would be a table, which as you pull it widescreen, additional columns become available to the user. And as you shrink those columns into the narrower panel, essentially the columns get transposed to become rows. Question 2, where do we put the navigation bar? Well, there's really two main spots. I mean, of course, there's other crazy places you can put it, but from a standard perspective, it either goes on the top, the bottom, kind of the horizontal, or it goes on the vertical. Now, the problem with putting the panel on the left side, or the vertical, is that we already are becoming short on horizontal space. And putting the panel here is going to reduce the already precious horizontal real estate. The additional concern is that we have to put icons in this panel, and there's not room to write text, meaning that for new users, it may be more difficult to know exactly what these icons control. Of course, you could get around this by allowing this navigation panel to open up to view the exact text of what these icons are, or you could overlay text. But again, all of this is compromising the already limited horizontal space. Also, the left vertical navigation bar is not something that you see typically on mobile phones, nor typically on websites. It's more common to place the bar either at the top or at the bottom. Now, the question is, which should we do? I've become a huge fan for many years of bottom navigation panel menus. And finally, Google has adopted this as well. And it makes sense, right? Because as the phone size has increased, our thumbs as humans have not proportionately grown to catch up. And so we can't touch the icons at the top of our phone. And therefore, by putting the menu at the bottom of the phone, we're able to operate it very quickly with our thumb while using the application. And so I think generally a bottom navigation bar is the preferred method. Now, the question is, what if you have two navigation bars, where the second bar is subservient to the first navigation bar? Well, in this case, you could do it on the bottom, but it intuitively makes a bit more sense, and especially to new users, if the top bar is the bar which controls the primary settings, and then the secondary settings are in the secondary header. It's a little bit counterintuitive that it's upside down in this example, especially when you imagine this being on a desktop, where typically on desktops, the hierarchy really goes from top to bottom for most applications. And if you add a third bar, let's say a third navigation bar, which really edits the content of the panels, it makes more sense intuitively to have that hierarchy at the bottom of the application, where this green bar would edit what we're viewing here. It's a bit counterintuitive to put the least important bar at the top and then actually have the bar which controls and reconfigures the entire app at the bottom, especially for new users. So let's move forward and assume we want to use a vertically split application where we have the top primary header, we have the secondary header, we have the active workspace, and then we have the third navigation bar. I want to just show an example here of the active touch areas. For instance, in green, we see the area that your thumb can reach, and then you begin to get into the stretch and the ow area where you actually can't operate the menu. which raises a concern because we just identify that we're putting our most important menu right up at the top here. What can we do? Fortunately, there's an answer. Let's look at Twitter. In Twitter, you have the exact same top header right here. They actually have the primary header, a secondary header, and the way that the secondary header is activated is very slick. You're able to swipe the panels to the left or to the right, and this locks and tracks at the same time as that top navigation. This creates a really fast user interface experience, and you just have 4 coordinates, up, down, left, right. The user still can press on the individual buttons if they like to, but it's slower, it's more clunky, and as you can see, it's a bit harder to get your thumb to the top of the panel, but it's at least a good backup if the user isn't able to do this. And because Chrome does support touch events, this type of an interface is fortunately possible. I'm pretty sure. Here's another example. We have the Kindle Fire here. Look how fast you're able to cycle through. It's almost as if you were paging through a textbook or an actual paper file. And again, here's an Apple Photos, very quickly cycling through different sections. I love this style of navigation, of using left, right, up, and down to navigate it. I call it Cartesianal navigation because you really just use the primary directions, and we'll speak about this a little bit later. When we look at the header, you'll note that part of it scrolls off screen. But this design works really well because the moment that you end up using a device which has a slightly wider screen, it automatically adapts to the header. And we've seen increasingly more and more websites adopting this style of a horizontal scrolling header. Chrome and Google has been adding it to more and more of their pages. They just actually updated this bar here in the image panel, I think in the last week or so. I haven't seen it before. And in the most recent release of iOS on Mac 12, they again added more and more horizontal scrolls. And the reason is that you're able to adapt between different size devices really well. And here it is finally on the desktop. Very clean. You're able to see all the headings. No need to change the user interface structure. Let's summarize. We've identified that we can place the primary heading at the top. The secondary heading is a series of panels which may scroll off of the screen. And you can easily swipe between these panels by pulling the content left or pulling it right. And then there's at the bottom a tertiary navigation bar which allows us to control some more content. Now let's clean up these colors. It's not 1990 anymore. And this style here just looks a little bit better. And we'll add the patient's name at the top of the application. And we'll go ahead and move on to the next part. So this was the summary of our first principles derived multitasking workflow, which adapts to multiple screen sizes. I think it's pretty slick as far as able to move between content types quite quickly. Let's move into part 2 now, the different ways to group clinical data. I think that there's maybe 5 general ways you can think about grouping clinical data. I suspect there's certainly more. The first is the most common, and we're going to call it source. I derived the term source grouping actually from Larry Weed, who was the founder of the problem-oriented medical record. And this term comes out of the 1960s and 1970s. And the reason he called it source is because the individual sources of data are grouped together. The notes are together, the labs are together, the medications together, and the imaging together. And I suspect that this is in part because the lab would provide its own faxes and own reports. The medications were stored separate, and the imaging from the imaging department was separate. And so it intuitively made sense when you had a paper chart to store these files grouped together like this. And in some ways, it makes it easy to be able to look at all the labs together. or look at all the imaging together. But as Larry Weed said, what does an X-ray of the ear and head have to do with an X-ray of the knee? Sure, they came from the same machine, but when we really think about it from the point of view of the patient, these are two separate issues that are actually being investigated. And so he always proposed the reason of grouping things around the problem, or around the issue. And so what we can do is we can say this patient has 3 issues: HIV, diabetes, hypertension, and we can store our information not based on source, but based on issue. And I think this is a really great way to think about storing medical data. A different way to think about this concept is as a data capsule. You can imagine that it would be reasonably straightforward to program a data capsule for COPD. And you would be able to identify what types of investigations, when they're completed, should be pulled into the COPD data capsule. For instance, if the patient had a chest X-ray for tuberculosis screening, it would make sense that the COPD data capsule would pull in a copy of that chest X-ray because it knows chest X-rays are a valuable diagnostic tool in COPD. The data capsule itself is also a really good way to thread together all the relevant information around a particular issue. And this is particularly useful when care is so fragmented and occurs in so many care settings today. For instance, imagine that all the diabetes information was in a self-contained capsule. When the patient came into hospital and the clinicians needed to adjust the diabetic medications in hospital, they'd open the capsule, they would see the medications the patient is on, they would see the comorbidities, the previous investigations, the past medications they've tried, the different outpatient physicians who care for this patient's diabetes, and then the inpatient physicians could amend the diabetic medications, explain why they did so in the note, which was specifically threaded into the diabetes capsule, close the capsule, figuratively speaking. The patient is discharged to go home. And now when the patient comes to the outpatient department and to the outpatient clinic, and their physician in the outpatient world wants to further titrate their diabetes medications, they can look at the content of that diabetes capsule, see exactly what medications were changed, why it was changed, add to this compendium of information, and now all the information is self-contained and makes sense. And you can imagine how useful capsules could actually be in many other ways. For instance, if you had a patient with a complex syndrome or an autoimmune condition, and you as a clinician want to know if any of your medications which were treating the autoimmune condition were changed. You could, for instance, set a notification so that if any of the medications within the rheumatoid arthritis capsule changed, that you would then receive a notification. This is a much more precise and surgical way to do communications and follow-up and thread information compared to the current state, where at least in North America, typically one hospital or one clinic will just send a letter in a shotgun manner to every other physician which the patient has interacted with, and we don't actually thread the details together which we need. Anyway, sorry for the side tangent there about data capsules, but you get the importance of being able to group things together based on issue. And we'll see later why this actually makes our user interface really easy to operate. We'll move along here in the presentation to the second part of grouping data by time. Instead of viewing all the notes in diabetes together and the medications and the labs and the imaging separate, you could sort those items based off of those which are most recent to last recent. And sorting clinical information by time actually is probably the oldest method of clinical data storage. When you imagine old medical records being a compendium of random and assorted documents just stacked on top of each other. Sorting by time is also, I think, one of the most intuitive ways to read a medical record. Being able to read page after page as you see the evolution of a medical condition really makes it easy to understand what's going on with the patient. The other huge advantage by sorting for time is that if you imagine that you saw the patient here, this blue line is your clinical note, and then they were returning to see you here, all you need to do in order to catch up and know exactly what's gone on in that patient's care is read the information which is between your last encounter and the present time. So sorting by time is really, I want to do this for all the medical records that I see, because it's just such I think, a quick way to understand a patient's evolution of their symptoms and understanding of the diagnostic workup. Sometimes, though, you don't want the information separated by issue or by problem. You want to integrate it all together where you see the entire patient's timeline all in one row. Now, this could be quite a lot of information, which leads us to the fourth way to group information, by summary. You may want to just see an overview of that patient's chart to know what their issues are, who the doctors that write notes are and when they've last had care. You may want to know what imaging investigations have been done, what medications they're on, and what labs have most recently been done. So a summary view is essential to any medical record in order to properly convey information in a quick manner. And sometimes what you want to do is actually not have a summary of the entire record, but you want to have a summary of each individual issue. You want to know the notes, the meds, the labs, and the tests related to HIV, just as an overview. You may look at this summary page, for instance, the first time you log into that patient's chart if they're a new patient. Or potentially the summary page might have a certain amount of clinical decision support, where if there are particular tests, for instance, the creatinine should be repeated and followed up, those tests could be an open spot in the summary, and you would note very clearly that information is missing, and that would clue you in that it's something to follow up on. Now we move on to the last grouping, which I've called Bloodhound. This is the Sherlock Holmes. This is the detective workflow. In many ways, actually, this is typically the experience of how care actually is inside of the clinic or hospital. You have a problem or an issue and you're looking through the record, trying to understand a bit more about it. And you then come across a lab value from 5 or 6 years ago, and it's abnormal. Maybe it's a white blood cell count of 1. And then you ask the patient, do you remember why you had blood work then? Do you remember if you were sick or what was going on, December 1st, 2013? You may then need to make a lateral change and move away from reading clinical notes to go and dig up the original lab reports and try to compare. Had they had blood work before, blood work after? Is there a trend here? And then you may want to try to find some clinical notes by another clinician who had ordered some other labs to understand why they were ordering those labs in the first place. And then you may come across an investigative test. Bone marrow had been done. And you try to figure out, well, who ordered this bone marrow and now who's interpreted it? And then you go and you find the interpretation report. And then that report goes to the hematologist and you try to find their paperwork. And then you see that they've ordered some other blood tests. And then you try to find those blood tests. And then those blood tests lead to perhaps eventually a diagnosis and some medications. But then one of the medications stops. And you're reading through their medication reconciliation history and you can't figure out why it stopped. And then you have to go and try to figure out, okay, so in March 13th, 2012, you stopped this medication. Well, let's try to see if there's any clinical notes from around March 13th, 2012. And then you begin to look for clinical notes around that time to try to put together the story to see if any other tests or labs were done. And this is the workflow which is not uncommon, or at least for general internal medicine or for complex cases, where you end up having a very circuitous route to arriving at the final end result. And to simplify and to clarify what's happening here, the user is both going forward and backwards in time. They're jumping between different sources, going from labs to notes to encounters. They will be crossing multiple issues all at once. They sometimes want to see a summary, and then something in the summary clues them in that's abnormal, and then they need to go into detail into that source material. And this workflow is not supported by any of the clinical electronic medical record systems that I'm familiar with. But it's really crucial to be able to understand and sort through complex patients. In some ways, this is why some people sometimes prefer paper charts, because you are able to take this strange route back and forth through the information. Whereas when you try to do this type of a workflow typically on a computer, you end up moving from one panel to another tab, to another window, and it's really hard to put the story together. Let's just summarize these 5 views here. We have source grouped by major category. We can sort that source material into an issue. We can resequence it based on time. We can put all the issues together into one massive timeline, which we can then summarize. And then we can take that summary and put it back into each individual issue again. And then we ideally would like to allow a clinician to go on the Sherlock Holmes chase and try to figure out and piece together a medical diagnosis which hasn't been made yet. But we don't want to build 6 different interfaces, or actually, if some people imagine sometimes HIV, diabetes, oncology, each of these departments being their own interface. We don't want to build hundreds of interfaces. That's ludicrous. So I think there is a way to bring all this clinical data into one interface. And let's go through one option here. What we'll do is we'll just open up the screen to full screen here. We'll start with the source material. Notes, medications, labs, imaging, other. I don't feel too strongly on exactly what these categories should be. Should physical exam be its own tab, or is physical exam part of notes? Theoretically, are labs and imaging both, should they be considered tests, which allows us in the future to put genomic tests and sequencing and pathology reports, or should they be separate tabs? Should we use the other tab to hold quite a lot of information? Where do blood transfusions go? I'm not too dogmatic about this. I think this is an important part of conversation to really try to clarify. I think that the general principle that we probably need about half a dozen major buckets to put the source material into is the takeaway principle here. About half a dozen standardized buckets for information. And let's put these buckets into that secondary heading. There we go. Now we'll move on to the second part, onto the issues. We want to sort the record by everything or just by issue specific. Well, there's actually a pretty easy way to do this. We can take this information and put it into the primary heading. Now, the tabs in the secondary heading are showing information related to all, the entire patient chart. But we could click on the filter here, and instead, rather than just showing all, we could change it to show HIV. Or theoretically, we could show hypertension or diabetes or any other diagnosis they have. And in theory, this ability to sort the chart could actually get very creative. Could you sort it based on based on system, cardiology, respirology? Or could you potentially come up with symptom-based sorts, such as shortness of breath, arthralgias, myalgias? In many ways, this process of being able to go into a patient's file, extract all the information which is related to potentially their diabetes, and to show that in a synthesized manner is the work of the medical student and of the resident. They do this lackey work currently and then present to the consultant the nice simplified version of what the actual information is from the patient's history, from their physical exam, and from their past information in the chart. But you can do this actually quite easily just by changing this tab here on the top. One other nice feature is that instead of having to open up the tab manually, you could just swipe this to the left or to the right. And by swiping that first header left or right, you could cycle through the different issues that are available. we already talked about the idea of being able to configure the different source material around a particular data capsule. And I just want to underscore this point one more time. And this is the reason that the electronic health record in this case can be self-organizing and automatically configure. And we don't need to rebuild new modules for different programs. Because all we need to do is identify, we can go to a particular program or department and say, all right, for diabetes, what notes do you want to associate to this capsule? What medications do you want to prioritize? What labs do you want to prioritize? What imaging studies do you want to prioritize? And we come up with a schema for each individual program. This departments can get very creative. They can have multiple programs and sub-programs, or they can just have one big department program. But essentially some sort of a schema, some sort of, JSON. I'm not going to micromanage the back end of this, but I think that there is a way to scale auto-configuring user interfaces using this idea. The second important part of the auto-configuring self-organizing model is that it allows us to also add multiple programs at once. For instance, the user could select diabetes, hypertension, and view the information related to both of those conditions at the same time on the interface. There's always the concern of siloing information. If you only show the diabetes medications and only the labs related to that, you will lose the understanding of the patient as a whole, and you may make mistakes. And therefore, I think when the interface auto-configures itself, rather than only showing medications related to diabetes, what I would prefer to see is the medications related to diabetes be pulled into a panel at the top, and then we show the other medications on a panel right below. Same with labs. We could show the specific labs of interest at the top and the other labs below. Or the other option would be that we show everything sorted based on the sort preferences of the user, and then we place in bold the objects which are related to the capsule that we're sorting. So we would put, for instance, the clinical encounters, which are related to diabetes, in bold, and then you would still be able to see that the patient has had numerous other encounters at other clinics for other issues before they came back for another diabetes encounter. So it allows us to both hone in on the information related to the task at hand and at the same time be able to not lose a global perspective of the patient. All right, let's move into the timeline view and the summary view, which were two other ways to sort the information. Let's just put timeline right beside notes, and let's place summary right beside timeline. Now, the user is able to, we'll just open this up here, quickly skim left or right through the interface to view the entire timeline and an overview of the patient. You can go to the summary and view a summary of that particular issue. If you clicked on an item in the summary or the timeline, it would scoot over automatically to open that up in the respective source material. Or you could yourself move through the notes, the meds, and the labs as if you were very quickly flipping through a paper chart. There's a few things we need to add to this interface. For instance, what about all the important information about the patient? Their demographics, their birth history, their family history, their social history, their financial history, their contact information. That hasn't been left out. It also can be put in as a tab. And the tab could be at default perhaps recessed just to the left off screen. And so if you want to get it, you just essentially were to swipe here to the left side, and then you would be taken to that panel. I suspect the default panel when you open a chart would be either a patient summary or a patient timeline. We need a few more things. For instance, the ability to search for a patient is very useful, so we can add that in. And when I place the search button on the interface, it's not to search for a new patient. The search is to search within the patient's chart. It's still a work in progress, but the search feature closely corresponds to the timeline. And the reason for this will be that you will want to be able to take the timeline and refine the search. For instance, to only show information from a particular hospital or a particular clinician or a particular date range. And being able to have the filters for the timeline built in concurrent to the way that the search operates will allow us to minimize the duplication of efforts between these two. Similarly, I suspect a lot of power users who use their keyboards will actually navigate most of the record by either just directly searching for objects and pulling them up as they require them, or they may use their keyboard to, for instance, hold the function key down, and then you could see a number appear over each item, and then you could, for instance, go control, and it would show 3 here, and you then just click 3 to take you automatically to that time. We know that in the past, shortcut keys were exceedingly problematic in that most users don't memorize them. And as we'll see a bit in the future, I don't think you would actually need to memorize any shortcut keys in order to operate this interface. Because we are using Cartesian navigation, which is entirely something bogus that I made up, moving left, right, up, or down, you can replicate that interface, that navigation and gesture pattern that it's used on the mobile phone and the tablet simply on the desktop by using the up, down, left, right arrow keys. Which means that in theory, you could quickly navigate a patient chart with one hand, which would allow you to have much better interaction with the patient because you don't need 2 hands and a mouse and your full attention to try to actually click on peripheral menu options. Let's move now into part 3, some ideas on interface panel designs. And again, these are very early. Essentially, the moment that I finished the presentation, there were many things I wanted to go in and change and I don't like about them. But we'll start again with the concept that we were talking about of Cartesian navigation. Look how fast it is to open an object, to close an object, to open a summary of the object, to scroll through that summary, to go back to the higher level, to now open a higher level summary of the object, go back to the original thread. This ability of going up, down, left, right, and clicking on small objects on the screen, I think, is an interface that we can replicate. And it's entirely the opposite of the standard user interface that we used to design on desktops. In the past, we would essentially design from the outside in. We would put menus at the top, so on the left and on the bottom. And in order to control your content and work through the application, you really spent your time on the periphery of the app changing toolbars. Whereas in mobile, we spend almost all of our time in the center of the app using one of 4 Cartesian directions plus a click, which, as we mentioned, can easily be replicated using your keyboard. There's also some other nice benefits because in theory, if you had a virtual reality or an augmented reality electronic health record, your ability to control that record using gaze may best be suited for looking left, right, up, or down, rather than having to operate menus and submenus in an augmented reality gaze-controlled interface. But we aren't there yet, so we won't worry about that. I think the big takeaway also from this Twitter experiment is to see that there's different layers and different levels of interface detail. For instance, you could imagine that there are primary, secondary, and tertiary layers of detail. And we can almost standardize an approach like this across our different types of source material, notes, medications, labs, imaging, etc. I'm not dogmatic whether it has to be exactly 3. I think some examples 2 might be fine and some may need 4. But essentially, you have a progression where there's a higher level, let's call it a primary level, which is a summary view. In this case, a summary of the medications the patient is on and their allergy. You could click on a medication and you're taken to the secondary view. And in the secondary view, in this case, it's configured to show the past metformin prescriptions with the dose increases at each time. And then you can click on a particular medication to view the detail view or the third level view, which shows prescriber details and dispensing details. And one way may be to see this easier is within the application. Again, you can click on metformin, you can click on the secondary, and now you're in the third level. And just like Twitter, you could, from the left, you could swipe to go back layers to the home. Now, if there is a problem on the Twitter app, the way that you go back is by a hard left, meaning that you start on the far extremity and then you pull into the middle of the screen. But if you do that in Google Chrome, you actually end up going back a page. So therefore, the way that we could get around this would be if you use 2 fingers to swipe left, to pull the panel to the right, that then you'd be able to go back. And Chrome Touch Events does allow the use of 1, 2, and 3 finger contact events and the corresponding touch events with that. So it is possible. Let's look at another example for labs. This could be a summary view, for instance, of the labs where you see the different labs and some recent results. You could perhaps change from a grid to another view type, such as sparklines, which we won't go into here, but this is, one of Edward Tuffy's great contributions to quantitative information display. And you could click on the hemoglobin, and it would take you to a summary view. This would be the secondary level view here, where you have the past history of their hemoglobin values. And then you could click on a particular one to get to the detail view, where you would understand when the sample was drawn and who ordered it. And you'd actually be able to see the other tests that were ordered at the same time and the note that ordered those tests. So you could then very quickly hyperlink by clicking on here to open up the note right away. I haven't had a chance to build out these views for notes or for patient history or for tests or imaging, but you can imagine a cascading sequence of overview, object summary, and object detail. Now, the issue is that deciding on what the summary view should be could be a contentious issue. For instance, someone may prefer to not have a grid and instead to have a graph, or someone might want it to be a sparkline, or someone might want to sort it by test, or by result date, or by test date, or by unreported results, or by abnormal results. Now, we don't want to build 12 different lab views at the start. And therefore, what we could do is separate the requests on ways to configure the summary into 2 categories: view and sort or group. Meaning that we could put all the different ways that a summary panel could have its view changed into one category, and the different ways that the users may want to sort into the group category. And this list can continue to grow with time. The examples shown here are just a few examples. I think speaking to more users could come up with quite an extensive list. And you can imagine doing this not just for labs, but the standard approach for medications, for notes, for imaging, for all these major source tabs that we have across the second header. And it actually is pretty awesome because you could go and have one standard imaging summary, but then if they want, you could configure it to just show X-ray or just CT or just MRI. You could change how you sort that study. And it allows us to have a certain amount of simplicity and structure in the style of the application, while really allowing almost infinite flexibility in the way that users configure and work within that framework and structure. Let's look at just another example here. This is the timeline view, for instance. You could have some objects of different types. This is a horizontal slide object, which is permitted, even though we know that pulling this panel generally left or right will change the secondary menu. It is used in other apps by real designers, a horizontal slide within the larger panel. The issue is that you can't have too large of an area, which is a horizontal slide, because then you have competing and overlapping slide areas. The text could be expanded, for instance, so that you could almost never have to leave the timeline view when you're reading through a patient's chart. You could just read it sequentially and continue to expand as you want. Or you could have in the view category the ability to view a small timeline snippet or an extended timeline snippet, again, depending on the user's preference. There's also the option, which is kind of cool, to be able to pull down on the timeline and then view notes or tests or procedures which will be happening in the future. And so the timeline doesn't have to be limited to the past, but can also let the user know what is coming up in that patient's care. And so I think the timeline would be probably my favorite part of the interface and really what I would go to whenever I'm seeing a patient, especially in the outpatient world, or if you're seeing a new consult. Now, there may be times where you want to go to the summary view, and of course, you could use summary as well. Moving on, one thing which users do when they have paper is they'll extract different parts of the paper chart, medication list, several tests, several imaging studies, and they may lay them on their desk and look across these tests from different times and piece together a story, or especially important when doing a dictation or a consultant note. And this type of workflow has been really hard on electronic medical records because traditionally the information is stored in different panels, and you can't link information from different panels and different time sequences together. A simple workaround could be perhaps putting a bookmark icon and allow the user to take any discrete object in the record and to bookmark it. And you have two ways you could bookmark something. You could either add it to your favorites, which is really just a short working list as you scroll through a timeline and you see records and notes that you want to come back to, or surgical reports or pathology reports. You could just star them right in the timeline as you do on any traditional social media app. And then conversely, if you want, you could be more specific and actually add an object to a particular bookmarked list, such as if you came across an imaging report that you wanted to save to a teaching file, or if you had a complex patient that several clinicians were working on together, you could have a group list where you shared what you thought were relevant facts about the case that people should look at together. Another idea, and this is very much in early development, I think we really need to prototype this out and see how it works, but it's the idea of the bloodhound workflow, where you have very asymmetric workflows. And one way to make that work is to put in a mini timeline. And the reason that this is useful is that whenever you're looking at a particular object on the main part of the app, in the mini timeline, you could see the exact sequence of what tests or what labs or notes or reports or imaging or orders were done before or after this object. And you can pull this left or right to scrub back and forth, or you could just click along this to read through a patient's chart. This is similar in some ways to on the iPhone in iMessage. There's this bar here where you can have different icons, and then you can actually click on one, and then the bar expands, which allows you to get more information or more level of detail into this tiny bar when it's in its resting state. Whether this can be pulled off in current Chrome, CSS, and HTML, I think remains to be seen. I think it's possible. But again, the main impetus is to add context so that when you do see a piece of information in the chart, you can very quickly tie it to understand what was happening before and after that particular result. We'll move on now to the part of the record which we haven't really looked at yet, which is the whole other half, the action panel. Now, admittedly, these mock-ups are even more rough than some of the other mock-ups we've been looking at. I think the action panel needs a whole separate series of lectures and work on to really understand how to design it best. But creating an action panel is difficult because the workflows vary quite a lot. You know, an oncology initial appointment is very different than an oncology chemotherapy appointment. And that's different than an outpatient HIV appointment at the dispensary in the village, which is very different from a cardiology inpatient EP appointment. One way to perhaps join this together is to have, let's say, 4 major sections: home, or actually I'd prefer it to be start, work, order, and cart. I think these names are stupid. They should be improved, and I hope someone does. But the concept would be that on the start page, this is what you would open when the chart opens right away. It would show maybe some upcoming visits the patient has, perhaps the visits of the day. If the clinical reminder system has particular items which need to be addressed, those could be displayed, and perhaps some past visits could be also displayed, and you could always add in other issues. So you could imagine opening a patient's chart for the first time. You have on the left a timeline where you see all the items which have just happened, and then you can go through and you can select what you want to address that day in clinic. For instance, you want to do HIV, standard care, the nutritionist is in, so they should see the nutritionist. Hypertension also will be followed up in this visit, and then we'll look at that TB screen. So the start page is really your configuration. It's your patient overview. It's the first thing you look at when they come in to start a workflow. Then you move into the workflow, and that's the work tab. And this looks horrendous, but the concept is there's going to be different people which need to be involved in the workflow. Each person is going to have different steps that they go through. We here at AMPATH use quite a lot of question-driven workflows for our outpatient encounters with discrete drop-down responses. And so users could essentially scroll through that workflow. And the really important thing to realize is that the action panel is not cut off from the clinical workflow panel. They're connected. Meaning, if you were, for instance, in a workflow here related to HIV, the interface could be linked. It would automatically update this section to filter for HIV information. And as you go in to specifically the part of the workflow where you're in the medication review section, again, it would bring up the current medications on the timeline here. As you get to the section where there's the physical examination, it would again configure to show the physical examination on the other side. And so these two halves of the system are always working in harmony with each other. In theory, you could always go in and you could unlink the two sides, and therefore you'd be able to look around the clinical information panel without it being reflected in the action panel. But the thought is that the action panel can control and edit your clinical workflow. And conversely, if you were in the clinical workflow, if you were in the clinical note looking at lab results, let's say a potassium, you could click on the potassium and then it would automatically open up the action panel to the orders page where you could have orders that you could do to respond to that issue, or you could add clinical commentary or notes related to the particular test or item or note or letter that you're interacting with. And so these are two halves which actually could interact with each other. Moving along, there could be a panel for orders where if the order isn't actually included as part of the clinical workflow. And then ultimately the notes get brought into the cart as well as the orders, and then they need to be finally signed off on before you submit them. So this is a work in progress. And if there's clinical reminders in the decision support which haven't been addressed yet, they can also alert the user here that there's issues. A few other things, just wrapping this up. We haven't addressed the home button. So we could add a home button in, and if you press the home button, it takes you out of the clinical chart and back to the main screen. The patient main screen would need some area where you could search based on patient identifier. There would need to be a patient list of sorts. Ideally, this would self-generate and configure based off of your user profile type and the clinic that you're in. So it would know, for instance, that you're a physician in the HIV clinic and then show you a list of the patients in HIV clinic which are currently ready for the physician as part of that workflow process. There's a lot more which needs to be built out. This is just some ideas. You have a hamburger menu where you can take you to data analytics, to lab order searches, or essentially information which is not part of the core patient chart, could be outside of the chart. And there's, infinite other things which could be added, such as messaging systems, ongoing education systems, clinical training, education systems, all from this main homepage. And there we have it. Let's just summarize a little bit about what we've talked about today in the last hour. We started with some first principles, looking at the fact that vertical screen height is very important because it allows you to read and to have a larger workflow before you have to click and scroll up to get to more content. Therefore, prioritizing devices held in portrait. We knew that multitasking is very important, and therefore we wanted to settle on a shape which is malleable enough to be used both on tablet, on phone, and on desktop, which is this long vertical column, meaning that the components we designed for one system can apply to the other types of screens. We looked at different ways that information can be stored, from source, for instance, and how those tabs can go across the top, how the source tabs can be then configured based off of the issues with the heading above the source heading, and we can, in addition, sort by timeline, which I think is really cool, or by summary, which will be also helpful. And in addition, some users will have this bloodhound and detective work that they have to do, which is very different every time they go about doing that. And to make that workflow easier, we have added a mini timeline where every object viewed on the screen can be seen in the context of the clinical care that it derives from. The app focuses on the concept of Cartesianal navigation, which is not a real term. It has been made up. And this is essentially moving up, down, left, and right as the primary mode of navigation. There are menu bars on the outside of the app, but these are not actually needed to use to drive the workflow. And the reason for this is because that's actually how most of the most popular apps on phone operate. And I suspect the reason for that is one, because it's very fast, and two, by having multiple levels of data, as we looked at having primary, secondary, and tertiary views for the different notes, for the labs, for the tests. Using Cartesian navigation, you can actually work through the information. As things catch your interest that you want to learn more about, you can click on them on the screen and you're always taken to the next panel. And if you get too far down one trail, you can always swipe back and go up higher and higher levels until you're back at the place you wanted to start. We looked finally at the action panel with just some very early concepts on how a workflow can be developed on that side, how the action panel can influence the information on the clinical view side of the application. And we are essentially done. And so this is, as I say, very much a prototype. It's not meant to anywhere be the end result, either for design or for the principles. I think right now, the main goal that we're trying to arrive at is, as I said, getting direction and feedback on the overall interface framework, meaning the concept of splitting the screen, of being able to pull the split screen left or right, of having that primary heading and the secondary heading, which you can swipe left and right at. Because what we really need to do is build out an HTML, CSS, very skeleton, bare bones prototype. And it doesn't need to be connected to any backend data, but we just need to see if we can actually make this work. See that the touch events in the Chrome browser do work. Make sure that the load page and time is sufficient. And that's the work on what I would say would be the next step. As far as actually trying to work towards a vision like this, there's significant work which also needs to be done on the back end in the way which the information is categorized, sorted, and stored, which would allow users to be very able very quickly to reconfigure the interface based off of their preferences. And so that's a much more difficult problem and a much longer road. And so in order to get started, I think the first thing would be to try to get feedback on the overall general framework so we can build a very general outline, and then continue to iterate and to develop with more specificity the actual panels and the actual components which can be used between the different screens and the different applications. I think that part is much more uncertain. Anyway, this has been a really fun project to work on. I've really enjoyed it, and thank you sincerely for your time. Please contact me with any questions, of course. As you could tell, I would be more than happy to talk about this in more detail in the days to come. Thank you.